Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Machine Learning Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are working with a dataset that contains customer transactions. You need to build an ML model to predict customer purchase behavior. You plan to develop the model in BigQuery ML and export it to cloud storage for online prediction. You notice that the input data contains a few categorical features, including product category and payment method. You want to deploy the model as quickly as possible. What should you do? The options are: Option A, use the transform clause with the ml.one_hot_encoder function on the categorical features at model creation and select the categorical and non-categorical features. Option B, use the ml.one_hot_encoder function on the categorical features and select the encoded categorical features and non-categorical features as inputs to create your model. Option C, use the create model statement and select the categorical and non-categorical features. Option D, use the ml.multi_hot_encoder function on the categorical features and select the encoded categorical features and non-categorical features as inputs to create your model.
To arrive at the correct answer, we focus on the keywords BigQuery ML, categorical features. Deploy the model as quickly as possible.
The correct answer is option C. Use the create model statement and select the categorical and non-categorical features.
Why is this correct? C. BigQuery ML automatically handles one-hot encoding for categorical features during model creation. Using the create model statement directly without manual pre-processing is the fastest way to develop and deploy. Why are the others incorrect? A. Using the transform clause with ml.one_hot_encoder is unnecessary because BigQuery ML automatically one-hot encodes categorical features. This adds redundant steps, violating the need for quick deployment. B. Manually applying ml.one_hot_encoder is redundant. BigQuery ML natively handles categorical features by default, making manual encoding an unnecessary slowdown. D. ml.multi_hot_encoder is not needed. BigQuery ML automatically encodes categorical features, so applying this function manually is inefficient and slows down the process.
You are developing an ML model that uses sliced frames from video feed and creates bounding boxes around specific objects. You want to automate the following steps in your training pipeline: ingestion and pre-processing of data in cloud storage, followed by training and hyperparameter tuning of the object model using Vertex AI jobs, and finally deploying the model to an endpoint. You want to orchestrate the entire pipeline with minimal cluster management. What approach should you use? The options are: Option A, use Kubeflow pipelines on Google Kubernetes Engine. Option B, use Vertex AI pipelines with TensorFlow Extended (TFX) SDK. Option C, use Vertex AI pipelines with Kubeflow Pipelines SDK. Option D, use Cloud Composer for the orchestration.
To arrive at the correct answer, we focus on the keywords: automate the following steps in your training pipeline, Vertex AI jobs, deploying the model to an endpoint, orchestrate the entire pipeline, minimal cluster management.
The correct answer is option C. Use Vertex AI pipelines with Kubeflow Pipelines SDK.
Why is this correct? C. Vertex AI pipelines offers serverless orchestration, fulfilling the minimal cluster management requirement. The Kubeflow Pipelines SDK seamlessly integrates with Vertex AI jobs and endpoints for ML workflows. Why are the others incorrect? F. Kubeflow Pipelines on Google Kubernetes Engine requires you to actively manage the underlying GKE cluster, which directly contradicts the requirement for minimal cluster management. B. The TFX SDK is specifically tailored for TensorFlow-based workflows. The Kubeflow Pipelines SDK is the more flexible and recommended standard for general ML pipeline orchestration on Vertex AI. D. Cloud Composer is intended for broader data engineering orchestration. Vertex AI Pipelines is purpose-built for ML pipelines and provides tighter, native integration with Vertex AI services.
You are an ML engineer at a travel company. You have been researching customers' travel behavior for many years, and you have deployed models that predict customers' vacation patterns. You have observed that customers' vacation destinations vary based on seasonality and holidays. However, these seasonal variations are similar across years. You want to quickly and easily store and compare the model versions and performance statistics across years. What should you do? The options are: Option A, store the performance statistics in Cloud SQL. Query that database to compare the performance statistics across the model versions. Option B, create versions of your models for each season per year in Vertex AI. Compare the performance statistics across the models in the Evaluate tab of the Vertex AI UI. Option C, store the performance statistics of each pipeline run in Kubeflow under an experiment for each season per year. Compare the results across the experiments in the Kubeflow UI. Option D, store the performance statistics of each version of your models using seasons and years as events in Vertex ML metadata. Compare the results across the slices.
To arrive at the correct answer, we focus on the keywords, store and compare the model versions and performance statistics across years.
The correct answer is option D. Store the performance statistics of each version of your models using seasons and years as events in Vertex ML metadata. Compare the results across the slices.
Why is this correct? D. Vertex ML metadata is purpose-built for tracking ML artifacts, lineage, and execution metadata. It easily stores and compares model performance statistics across data slices like seasons and years. Why are the others incorrect? A. Cloud SQL is a generic relational database requiring custom schema design and logic for ML tracking. It lacks native ML artifact versioning and slice comparison capabilities. B. Creating separate models for every season per year does not scale well. The Evaluate tab is not designed for complex, multi-year cross-slicing comparisons of model performance. C. While Kubeflow tracks pipeline runs, Vertex ML metadata is specifically designed as a scalable metadata store to analyze custom metrics and compare slices across different events natively.
You have recently developed a new ML model in a Jupyter notebook. You want to establish a reliable and repeatable model training process that tracks the versions and lineage of your model artifacts. You plan to retrain your model weekly. How should you operationalize your training process? The options are: Option A, 1. Create an instance of the custom training job class with the Vertex AI SDK to train your model. Point 2. Using the Notebooks API, create a scheduled execution to run the training code weekly. Option B, 1. Create an instance of the custom job class with the Vertex AI SDK to train your model. Point 2. Use the metadata API to register your model as a model artifact. Point 3. Using the Notebooks API, create a scheduled execution to run the training code weekly. Option C, 1. Create a managed pipeline in Vertex AI Pipelines to train your model by using a Vertex AI custom training job op component. Point 2. Use the model upload op component to upload your model to Vertex AI model registry. Point 3. Use Cloud Scheduler and Cloud Run functions to run the Vertex AI pipeline weekly. Option D, 1. Create a managed pipeline in Vertex AI Pipelines to train your model using a Vertex AI hyperparameter tuning job run op component. Point 2. Use the model upload op component to upload your model to Vertex AI model registry. Point 3. Use Cloud Scheduler and Cloud Run functions to run the Vertex AI pipeline weekly.
To arrive at the correct answer, we focus on the keywords, reliable and repeatable model training process, tracks the versions and lineage of your model artifacts. Retrain your model weekly.
The correct answer is option C. 1. Create a managed pipeline in Vertex AI pipelines to train your model by using a Vertex AI custom training job op component. Point 2. Use the model upload op component to upload your model to Vertex AI model registry. Point 3. Use Cloud Scheduler and Cloud Run functions to run the Vertex AI pipeline weekly.
Why is this correct? C. Vertex AI pipelines establishes a reliable, repeatable process that automatically tracks artifact lineage. Cloud Scheduler and Cloud Run functions enable robust weekly execution. Why are the others incorrect? A. Scheduled notebook executions are not robust for production and do not automatically track the lineage and versioning of model artifacts. B. Although the metadata API registers artifacts, using scheduled notebook executions lacks the reliable, repeatable workflow structure and automated lineage tracking of Vertex AI pipelines. D. The scenario requires standard model training rather than hyperparameter tuning, making the custom training job op component appropriate instead of the hyperparameter tuning job run-op.
You are an ML engineer at a bank. The bank's leadership team wants to reduce the number of loan defaults. The bank has labeled historic data about loan defaults stored in BigQuery. You have been asked to use AI to support the loan application process. For compliance reasons, you need to provide explanations for loan rejections. What should you do? The options are: Option A, import the historic loan default data into AutoML. Train and deploy a linear regression model to predict default probability. Report the probability of default for each loan application. Option B, create a custom application that uses the Gemini Large Language Model, LLM. Provide the historic data as context to the model, and prompt the model to predict customer defaults. Report the prediction and explanation provided by the LLM for each loan application. Option C, train and deploy a BigQuery ML classification model trained on historic loan default data. Enable feature-based explanations for each prediction. Report the prediction, probability of default, and feature attributions for each loan application. Option D, load the historic loan default data into a Vertex AI Workbench instance. Train a deep learning classification model using TensorFlow to predict loan default. Run inference for each loan application, and report the predictions.
To arrive at the correct answer, we focus on the keywords, labeled historic data about loan defaults stored in BigQuery, provide explanations for loan rejections.
The correct answer is option C, train and deploy a BigQuery ML classification model trained on historic loan default data. Enable feature-based explanations for each prediction. Report the prediction, probability of default, and feature attributions for each loan application.
Why is this correct? C. BigQuery ML classification directly leverages the existing BigQuery data. Enabling feature-based explanations, feature attributions, satisfies the compliance requirement to accurately explain loan rejections. Why are the others incorrect? A. Linear regression is inappropriate for binary classification tasks like loan defaults. Additionally, this approach does not provide the required feature-based explanations for loan rejections. B. LLMs are not designed for structured tabular data classification, and their generated explanations are non-deterministic, lacking the mathematical feature attribution required for strict compliance. D. A standard TensorFlow deep learning model acts as a black box and does not natively provide feature-based explanations, failing to meet the core compliance requirement.
You work for a large retailer, and you need to build a model to predict customer churn. The company has a dataset of historical customer data, including customer demographics, purchase history, and website activity. You need to create the model in BigQuery ML and thoroughly evaluate its performance. What should you do? The options are: Option A, create a linear regression model in BigQuery ML, and register the model in Vertex AI Model Registry. Use Vertex AI to evaluate the model performance. Option B, create a logistic regression model in BigQuery ML, and register the model in Vertex AI model registry. Use ml.arima_evaluate function to evaluate the model performance. Option C. Create a linear regression model in BigQuery ML. Use the ml.evaluate function to evaluate the model performance. Option D. Create a logistic regression model in BigQuery ML. Use the ml.confusion_matrix function to evaluate the model performance.
To arrive at the correct answer, we focus on the keywords, predict customer churn, BigQuery ML, thoroughly evaluate its performance.
The correct answer is option D. Create a logistic regression model in BigQuery ML. Use the ml.confusion_matrix function to evaluate the model performance.
Why is this correct? D. Customer churn is a binary classification problem, making logistic regression the correct choice. ml.confusion_matrix is an appropriate built-in BigQuery ML function to thoroughly evaluate a classification model's performance. Why are the others incorrect? A. Predicting churn is a classification task, making linear regression an inappropriate model choice. Additionally, native BigQuery ML evaluation functions are preferred over using Vertex AI for basic evaluation. B. Although a logistic regression model is correct for classification, the ml.arima_evaluate function is designed exclusively for evaluating ARIMA time series forecasting models, not classification models. C. Predicting customer churn is a classification problem, not a continuous prediction problem, meaning a linear regression model is fundamentally incorrect for this use case.
You are building a real-time prediction engine that streams files which may contain personally identifiable information, PII, to Google Cloud. You want to use the Cloud Data Loss Prevention (DLP) API to scan the files. How should you ensure that the PII is not accessible by unauthorized individuals? The options are: Option A, stream all files to Google Cloud, and then write the data to BigQuery. Periodically conduct a bulk scan of the table using the DLP API. Option B, stream all files to Google Cloud, and write batches of the data to BigQuery. While the data is being written to BigQuery, conduct a bulk scan of the data using the DLP API. Option C, create 2 buckets of data, sensitive and non-sensitive. Write all data to the non-sensitive bucket. Periodically conduct a bulk scan of that bucket using the DLP API, and move the sensitive data to the sensitive bucket. Option D, create 3 buckets of data, quarantine, sensitive, and non-sensitive. Write all data to the quarantine bucket. Periodically conduct a bulk scan of that bucket using the DLP API, and move the data to either the sensitive or non-sensitive bucket.
To arrive at the correct answer, we focus on the keywords, streams files which may contain personally identifiable information, PII, ensure that the PII is not accessible by unauthorized individuals.
The correct answer is option D, create 3 buckets of data, quarantine, sensitive, and non-sensitive. Write all data to the quarantine bucket. Periodically conduct a bulk scan of that bucket using the DLP API, and move the data to either the sensitive or non-sensitive bucket.
Why is this correct? D. Placing incoming files in an inaccessible quarantine bucket ensures PII is never exposed. The DLP API can safely scan and route data to the appropriate secured bucket. Why are the others incorrect? A. Writing potentially sensitive data directly to BigQuery exposes PII to users with BigQuery access before the periodic scan can identify and secure it. B. Even with batch scanning during the write process, PII might land in BigQuery and become accessible to unauthorized users before it is properly secured. C. Writing incoming data to a non-sensitive bucket immediately exposes any PII it contains to users with access to non-sensitive data, violating the security requirement.
You work for a bank. You need to train a model by using unstructured data stored in cloud storage that predicts whether credit card transactions are fraudulent. The data needs to be converted to a structured format to facilitate analysis in BigQuery. Company policy requires that data containing personally identifiable information, PII, remain in cloud storage. You need to implement a scalable solution that preserves the data's value for analysis. What should you do? The options are: Option A, use BigQuery's authorized views and column-level access controls to restrict access to PII within the dataset. Option B, use the DLP API to de-identify the sensitive data before loading it into BigQuery. Option C, store the unstructured data in a separate PII-compliant BigQuery database. Option D, remove the sensitive data from the files manually before loading them into BigQuery.
To arrive at the correct answer, we focus on the keywords: unstructured data stored in cloud storage, converted to a structured format to facilitate analysis in BigQuery, data containing personally identifiable information, PII, remain in cloud storage, implement a scalable solution that preserves the data's value for analysis.
The correct answer is option B, use the DLP API to de-identify the sensitive data before loading it into BigQuery.
Why is this correct? B. The DLP API automates the detection and de-identification of PII in unstructured data. This ensures PII remains in cloud storage while transforming the data into a structured format, preserving its value for BigQuery analysis in a highly scalable manner. Why are the others incorrect? A. Loading the data into BigQuery first violates the strict company policy that personally identifiable information, PII, must remain in cloud storage. C. BigQuery is designed for structured data analysis. Storing unstructured data directly in BigQuery does not fulfill the requirement to convert it to a structured format. D. Manually removing sensitive data from files is highly unscalable and prone to human error, violating the requirement for a scalable solution.
Your team is developing a customer support chatbot for a healthcare company that processes sensitive patient information. You need to ensure that all personally identifiable information, PII, captured during customer conversations is protected prior to storing or analyzing the data. What should you do? The options are: Option A, use the Cloud Natural Language API to identify and redact PII in chatbot conversations. Option B, use the Cloud Natural Language API to classify and categorize all data, including PII, in chatbot conversations. Option C, use the DLP API to encrypt PII in chatbot conversations before storing the data. Option D, use the DLP API to scan and de-identify PII in chatbot conversations before storing the data.
To arrive at the correct answer, we focus on the keywords: sensitive patient information, personally identifiable information, PII, protected prior to storing or analyzing.
The correct answer is option D, use the DLP API to scan and de-identify PII in chatbot conversations before storing the data.
Why is this correct? D. Cloud Data Loss Prevention, DLP, API is specifically designed to scan, classify, and de-identify sensitive data such as PII before storage or analysis, ensuring privacy and compliance. Why are the others incorrect? A. Cloud Natural Language API is designed for general text analysis, such as sentiment and entity recognition, and is not the specialized tool required for identifying and redacting PII. B. Cloud Natural Language API categorizes text but lacks the robust, purpose-built features needed to protect or de-identify sensitive PII for regulatory compliance. C. While the DLP API supports certain encryption methods, scanning and de-identifying is the comprehensive, standard terminology and capability for protecting PII prior to storage.
You need to build classification workflows over several structured datasets currently stored in BigQuery. Because you will be performing the classification several times, you want to complete the following steps without writing code: exploratory data analysis, feature selection, model building, training, and hyperparameter tuning and serving. What should you do? The options are: Option A, configure AutoML tables to perform the classification task. Option B, run a BigQuery ML task to perform logistic regression for the classification. Option C, use AI platform notebooks to run the classification model with Pandas library. Option D, use AI platform to run the classification model job configured for hyperparameter tuning.
To arrive at the correct answer, we focus on the keywords, structured datasets, without writing code.
The correct answer is option A, configure AutoML tables to perform the classification task.
Why is this correct? A. AutoML tables is specifically designed for structured datasets and automates the entire ML workflow, including exploratory data analysis, feature selection, training, tuning, and serving, without requiring you to write code. Why are the others incorrect? B. BigQuery ML requires writing SQL queries to train models, violating the explicit requirement to complete the steps without writing code. C. AI platform notebooks require writing custom code, e.g., Python, for data analysis and model building, contradicting the no-code requirement. D. AI platform requires writing custom training code and scripts to build, train, and tune models, which violates the requirement to perform these steps without writing code.
You manage a team of data scientists who use a cloud-based backend system to submit training jobs. This system has become very difficult to administer, and you want to use a managed service instead. The data scientists you work with use many different frameworks, including Keras, PyTorch, Theano, scikit-learn, and custom libraries. What should you do? The options are: Option A, use the AI platform custom containers feature to receive training jobs using any framework. Option B, configure Kubeflow to run on Google Kubernetes Engine and receive training jobs through TF Job. Option C, create a library of VM images on Compute Engine and publish these images on a centralized repository. Option D, set up Slurm Workload Manager to receive jobs that can be scheduled to run on your cloud infrastructure.
To arrive at the correct answer, we focus on the keywords, submit training jobs, difficult to administer, use a managed service instead, many different frameworks, custom libraries.
Correct answer is option A, use the AI platform custom containers feature to receive training jobs using any framework.
Why is this correct? A. AI platform custom containers allow running training jobs with any framework, dependencies, or custom libraries, fulfilling the requirement for a managed service that supports various ML frameworks without administration overhead. Why are the others incorrect? B. Kubeflow on GKE requires managing Kubernetes clusters and infrastructure, which contradicts the goal of replacing a difficult-to-administer system with a managed service. C. Managing a library of VM images on Compute Engine involves significant administration effort and overhead, failing to meet the requirement for a managed service. D. Setting up and maintaining a Slurm workload manager requires administering your own infrastructure, which directly conflicts with the desire to use a managed service.
Your organization wants to make its internal shuttle service route more efficient. The shuttles currently stop at all pickup points across the city every 30 minutes between 7 a.m. and 10 a.m. The development team has already built an application on Google Kubernetes Engine that requires users to confirm their presence and shuttle station one day in advance. What approach should you take? The options are: Option A, 1. Build a tree-based regression model that predicts how many passengers will be picked up at each shuttle station. 2. Dispatch an appropriately sized shuttle and provide the map with the required stops based on the prediction. Option B, 1. Build a tree-based classification model that predicts whether the shuttle should pick up passengers at each shuttle station. 2. Dispatch an available shuttle and provide the map with the required stops based on the prediction. Option C, 1. Define the optimal route as the shortest route that passes by all shuttle stations with confirmed attendance at the given time under capacity constraints. 2. Dispatch an appropriately sized shuttle and indicate the required stops on the map. Option D, 1. Build a reinforcement learning model with tree-based classification models that predict the presence of passengers at shuttle stops as agents and a reward function around a distance-based metric. 2. dispatch an appropriately sized shuttle and provide the map with the required stops based on the simulated outcome.
To arrive at the correct answer, we focus on the keywords: make its internal shuttle service route more efficient, requires users to confirm their presence in shuttle station 1 day in advance.
The correct answer is option C. 1. Define the optimal route as the shortest route that passes by all shuttle stations with confirmed attendance at the given time under capacity constraints. 2. Dispatch an appropriately sized shuttle and indicate the required stops on the map.
Why is this correct? C. Since users confirm their presence and station in advance, you have deterministic data. There is no need for machine learning. This is an optimization problem best solved by calculating the optimal route based on known attendance and capacity. Why are the others incorrect? A. Predicting passenger counts is unnecessary because the application already collects confirmed attendance data 1 day in advance. Using ML here overcomplicates a deterministic problem. B. Predicting whether a shuttle should stop is redundant since users already confirmed their stations beforehand. You already know exactly where to stop. D. Reinforcement learning is an overly complex approach for a problem where all variables, passenger counts and locations, are known deterministically in advance.
You developed a BigQuery ML linear regressor model by using a training dataset stored in a BigQuery table. New data is added to the table every minute. You are using Cloud Scheduler and Vertex AI pipelines to automate hourly model training and use the model for direct inference. The feature pre-processing logic includes quantile bucketization and min-max scaling on data received in the last hour. You want to minimize storage and computational overhead. What should you do? The options are: Option A, pre-process and stage the data in BigQuery prior to feeding it to the model during training and inference. Option B, use the transform clause in the create model statement in the SQL query to calculate the required statistics. Option C, create a component in the Vertex AI pipeline's directed acyclic graph (DAG) to calculate the required statistics and pass the statistics on to subsequent components. Option D, create SQL queries to calculate and store the required statistics in separate BigQuery tables that are referenced in the create model statement.
To arrive at the correct answer, we focus on the keywords: BigQuery ML, feature pre-processing logic, minimize storage and computational overhead.
The correct answer is option B. Use the transform clause in the create model statement in the SQL query to calculate the required statistics.
Why is this correct? B. The transform clause natively applies feature pre-processing logic during training and serving in BigQuery ML. This avoids external computation and eliminates the need to store pre-processed features or statistics, minimizing both storage and computational overhead. Why are the others incorrect? A. Staging preprocessed data duplicates data in BigQuery, significantly increasing storage overhead and violating the core requirement. C. Processing data in a Vertex AI pipeline component moves data out of BigQuery, adding unnecessary computational overhead and latency compared to native BigQuery ML preprocessing. D. Storing statistics in separate BigQuery tables adds unnecessary storage overhead and complexity when the transform clause can handle statistics computation on the fly.
You are developing an AI text generator that will be able to dynamically adapt its generated responses to mirror the writing style of the user and mimic famous authors if their style is detected. You have a large dataset of various authors' works, and you plan to host the model on a custom VM. You want to use the most effective model. What should you do? The options are: Option A, deploy Llama 3 from Model Garden and use prompt engineering techniques. Option B, fine-tune a BERT-based model from TensorFlow Hub. Option C, fine-tune Llama 3 from Model Garden on Vertex AI pipelines. Option D, use the Gemini 1.5 Flash foundational model to build the text generator.
To arrive at the correct answer, we focus on the keywords AI text generator, mirror the writing style, large dataset of various authors' works, host the model on a custom VM.
The correct answer is option C, fine-tune Llama 3 from Model Garden on Vertex AI pipelines.
Why is this correct? C. Fine-tuning Llama 3 on Vertex AI pipelines leverages your large dataset to accurately capture specific writing styles, and as an open weights model, it can be exported and hosted on a custom VM. Why are the others incorrect? A. Prompt engineering alone is generally less effective than fine-tuning on a large dataset for deeply learning and consistently mirroring complex, nuanced writing styles. B. BERT is an encoder-only architecture optimized for natural language understanding tasks like classification, making it unsuitable for generative text applications. D. Gemini 1.5 Flash is a fully managed proprietary model accessed via API. Its weights are not available to download and host on a custom VM.
You recently created a new Google Cloud project. After testing that you can submit a Vertex AI pipeline job from the Cloud Shell, you want to use a Vertex AI Workbench user-managed notebook instance to run your code from that instance. You created the instance and ran the code, but this time the job fails with an insufficient permissions error. What should you do? The options are: Option A, ensure that the Workbench instance that you created is in the same region of the Vertex AI pipeline's resources you will use. Option B, ensure that the Vertex AI Workbench instance is on the same subnetwork of the Vertex AI pipeline resources that you will use. Option C, ensure that the Vertex AI Workbench instance is assigned the Identity and Access Management (IAM) Vertex AI user role. Option D, ensure that the Vertex AI Workbench instance is assigned the Identity and Access Management (IAM) Notebooks runner role.
To arrive at the correct answer, we focus on the keywords Vertex AI pipeline job, Vertex AI Workbench user-managed notebook instance, fails with an insufficient permissions error.
The correct answer is option C, ensure that the Vertex AI Workbench instance is assigned the Identity and Access Management (IAM) Vertex AI user role.
Why is this correct? C. By default, Vertex AI Workbench user-managed notebooks use the Compute Engine default service account. To submit Vertex AI jobs, the service account attached to the instance must be granted the Vertex AI user IAM role to resolve the insufficient permissions error. Why are the others incorrect? A. While regional alignment is often required for resource interaction, a mismatch in regions would typically result in resource not found errors or routing issues, not an insufficient permissions error. B. Network placement and subnetwork configurations do not resolve identity-based authorization issues. An insufficient permissions error explicitly indicates an IAM role or permission deficit rather than a network connectivity problem. Why are the others incorrect? D. The notebook's runner role grants permissions to act on the notebook instance itself, such as starting or stopping it, but does not provide the permissions required to interact with or submit jobs to Vertex AI pipelines.